In this video, we'll review how to find the area of regular polygons. To find the area of a regular polygon, such as a hexagon, octagon, n-gon, decagon, we're going to do it through dissection. We're going to cut the figure into congruent triangles. The number of congruent triangles will match the number of sides. So for instance, this is a regular decagon. A decagon has 10 sides, meaning I can cut it into 10 congruent triangles. The other thing I'm told in this problem is that the length of the sides is 12 centimeters. We're going to find the area in the perimeter. Now I'm actually ready to do the perimeter because I'm told one of the sides. However, I don't know how tall the triangles are. I don't know the length of AD. So in order to find the area of the decagon, I need to know the base and the height of the triangle, which is where I'm going to proceed with. I'm going to find those dimensions before I find the area or the perimeter. To begin, triangle BAC is not a right triangle. I need to find the angle BAC up top so that I can cut it in half to find the angle of the right triangle. Angle BAC represents one of the 10 triangles. Each of those triangles together makes a full circle if I was to put them all together, which would be 360 degrees. That 360 degrees is then divided into 1/10 to find angle BAC, because BAC represents 1/10 of a full circle going all the way around. So if I take the 360 and divide by 10, I get 36 degrees, which represents the measure of angle BAC. Now again, that is not the angle of the right triangle. I need a right triangle because right triangles are what I can use for trig, or Pythagorean theorem, or special triangles. I can't do that if it's not a right triangle. So right now, triangle BAC is not something I could really use conveniently to find that length AD. However, if I look at the right triangle, which is angle BAD, I could use some trig on this. So the measure of angle BAD would be half of that measure of angle BAC, or half of 36 degrees, meaning that angle up there is 18 degrees. The other thing about that right triangle is if the whole length of the bottom BC was 12 centimeters, because that's the length of one of the sides of the decagon, then half of that would be the length of the right triangle, or the length of BD. So BD is 6, again, half of 12. I know that I have that angle up there of 18 degrees, and I'm ready to do some trig. Looking at the problem as angle BAD, or the 18 degree angle is my reference angle, I have BD given to me, which is opposite from it, and I really need the height AD, which would be the adjacent leg. Well, the trig function that uses the opposite and the adjacent would be tangent. So the tangent of 18 degrees equals that length 6 over AD. Solving for AD, I multiply both sides by AD, and then divide by tangent of 18. I get that AD equals 6 over tangent 18 degrees. Or, using my calculator, it's about 18.47 centimeters. Now I'm ready to find the area in the perimeter. Well, the perimeter is the distance around the figure. If this is a decagon, there are 12 sides, and I was given at the beginning that each side was 12 centimeters. So 10 times 12, or 120 centimeters, represents the perimeter of the decagon. Now the area is a little bit more difficult. The area is going to be the sum of the 10 triangles. Again, it's a decagon, so there's 10 triangles, 10 sides, 10 triangles. I knew the base of all the triangles. Each base of the triangle was 12 centimeters, but I didn't know the height until recently. I now know the height, AD, is about 18.47 centimeters. So to find the area, I'm going to say the area is the 10 triangles multiplied out. Now notice the approximation symbol there. The reason I have the approximation symbol is I've already thrown an approximated number. 18.47, the height of the triangle, is an approximation. Now each triangle is half of base times height, and I have 10 triangles, so I have 10 times half times base times height, or 10 times half times 12 times that 18.47. Again, now would be a good time to grab my calculator, multiply it out, 10 times half times 12 times 18.47, or half of 10 is 5, 5 times 12 is 60, 60 times the 18.47 is 1,108.20 centimeters squared. And again, it is an approximation, so make sure it has the approximation symbol. To review what we just did, when we approach these problems, we're going to find that central angle. Once we have that central angle, cut it in half, and then, depending on what that angle is, we'll either use trig or special triangles. We'll use that to find either the length of the sides or the height. Now, if we're given the radius, which would be AB, then I'd have to find both the sides and the height. Once I have those, I'm ready to find the area in the perimeter. Now remember, when you do the area, the number of triangles always equals the number of sides. So let's take a look at another example. Here we have the beginning of a regular octagon. I didn't draw the whole octagon out, but this is all I need to see. I have a regular octagon where the octagon is inscribed in a circle, then the circle has a radius of 20 feet. This is going to be the harder of the problems. In this case, if the radius is given to you, then you've got to go through and use trig twice to find the height of the triangle and the base of the triangle. Now, I want you to actually try this one on your own, please. Please pause the video, work this one out, and then check your answers. Don't just go through it without trying it. If you need to, watch the video, rewind it, and then try it on your own, and then check your answers. I'll give you a minute to work it through. All right, hopefully you've had a chance to do this problem, because that's really how you're going to learn how to do it. To begin again, I need to find the central angle, the measure of angle BAC. Well, this is an octagon. Octagons have 8 sides. So the measure of that central angle would be 360 divided by 8, or 45 degrees. Now for the right triangle, angle BAD, it's going to be half of 45 degrees, or 22.5 degrees. They gave me the length of AB. AB represents the hypotenuse to the right triangle, which means in order to find the pieces I need, I'm going to have to do trig twice. If I use the cosine, which is adjacent to hypotenuse, the adjacent represents AD, which is the height of the triangle. Solving this problem, I'm going to multiply both sides by 20, and I get AD equals 20 cosine of 22.5. Or using my calculator, it's about 18.48 feet. I also need to find the length of the sides. Well, BD would be half the length of the any side of the octagon. BD would be opposite from that 22.5, and 20 is still the hypotenuse, so I'm going to use sine this time. So the sine of 22.5 is BD over 20. Multiplying by 20 on both sides of the equation, I get BD equals 20 sine of 22.5. Or, that piece is about 7.65 feet. Now again, that's not the whole length of the side, that's half of a side of the octagon. So to find the side, I'm going to double that. Now while you still have 7.65, or more appropriately, the 20 sine of 22.5 on your calculator, hit times 2. Okay, do it from the value that's before you round it on the calculator, because it's possible it may be off a little bit when you double it. So if I double that 20 sine of 22.5, I get 15.31 feet. Now again, you notice this is a little bit off. If I had just doubled the 7.65, I would have got 15.30. But because it was rounded, and when I doubled it, it caught that there was a little bit of a rounding error, so I get the 15.31 feet. All right, to find the perimeter. The perimeter is the distance around, and the way we're going to find that is we're going to take the length of any side and multiply by how many sides there are. Octagon has 8 sides. We now know each side is 15.31 feet about, so the perimeter is about 8 times that 15.31 feet. Using my calculator, it's about 122.48 feet. Now that really should say rounding, that's an error on my part. It should say about 122.48 feet. Yeah, that is a typo on my part, and that really should say about. That's kind of bad. The area. The area is going to be the 8 triangles that make the octagon. So to find the area, I'm going to say it is 8 triangles, each one being half a base times height. Well, I know that the triangles have a height of about 7.65 feet, and we just figured out the sides are all 15.31, so I'm ready to find the area. So again, it's half of base times height times the 8 triangles we have, so that would be 8 times the half times the 15.31 times the 7.65. Using the calculator to multiply this out, we're going to see that the area is about 468.49 feet squared. So very similar to the last problem, find your central angle, cut it in half. If they don't give you the base and the height, use trig, or possibly special triangles, to make sure that you have both the base and the height. Once you have the base and the height of the triangle, you're ready for the perimeter and the area. Again, remember for the area, the number of triangles always equals the number of sides of the regular polygon. All right, so let's look at one more example. Now this next one is kind of a special case. We're going to find the area of a regular hexagon, and the hexagons work a little different than the others. Now in this case, it's inscribed in a circle again, so just like the last problem, it's inscribed in a circle, and they gave me the radius. Because they gave me the radius of the circle, I don't have either the base or the height of the triangle, so I'm going to have to solve for both of those. But in this case, we're going to see something a little different. So what I'd like for you to do, find the central angle, cut it in half, and get your triangle set up. If you recognize what to do, keep going. If not, resume the video and then check how I did it. Either way, you really should work this one out first before you actually go through and watch all the answers. So I'll give you a minute, pause the video, try working out. If you get stuck, go and hit resume. Otherwise, work it all the way out and then check your answers. All right, hopefully you've had a chance to work this out. It's a regular hexagon, meaning each of those triangles represents 1/6 of the whole figure. So 360 divided by 6 tells me that that measure of angle BAC is 60 degrees. Cutting that in half to find the angle for the right triangle, half of 60 is 30 degrees. Now that's a tip-off. If I have a 30-degree angle, and I have that 90-degree angle down where angle BDA is, I'm seeing that I got a 30, 60, 90 triangle. If I have a 30, 60, 90 triangle, I am not going to use trig for this. Instead, it's a special triangle. So I'm going to set it up as the special triangle, so the 30, 60, 90 triangle, where you have short leg, long leg, hypotenuse, in a ratio of n root 3 to n. Now this really, again, has a little bit of an error going here. I don't know what happened to my root 3. So I'm going to draw this in real quick. That should be an n root 3. Now when I go to resume the video, this root 3 is going to disappear, but keep in mind this really should be the n root 3. And you'll see in a minute what it looks like. Okay, we're told that the hypotenuse, which is the 2n piece, is 1. So plugging it in, we solve an equation. If 2n equals 1, then n has to be a half. The long leg, again, that should be n root 3. If the long leg is n root 3, plugging in half for n, I get that it's half root 3. The side length is not going to be BD. Okay, BD is half of a unit, but the whole length, BC, would be double that, which is, again, 1 inch. Now, if I go back to what I originally got for the measure of angle BAC, which is 60 degrees, well, angle B on the left and angle C on the right, or angles ABC and ACB, are also 60 degrees, which means this is an equiangular triangle. If it's equiangular, it's also equilateral for triangles, which means all of the sides of the triangle are 1 inch. So AC is 1 inch, AB is 1 inch, and even BC is 1 inch. Now I can also see that by looking at the short leg. If the short leg BD is half, and CD is half, half and half again is 1 inch. So I'm ready to find the area in the perimeter. To find the perimeter, I'm going to do that it's 6 sides. Each side is 1 inch. So again, saying that my sides are 1 inch, area would be 6 triangles, each triangle half of base times height. Half of the 1, which is the base, times the height, which is half root 3, would give me the 3/2 root 3 inches. Now I can also approximate that and figure an approximation, which would be about 2.60 inches. If I wanted to find the perimeter, which this one doesn't ask, I would just take the length of the sides, which I know are 1 inch, and multiply by the 6 sides that this has. The perimeter would be 6 inches. So again, to summarize, find the central angle, cut it in half. And this time, once we cut it in half, we saw that 30 degrees, which told me special triangle. It's a 30, 60, 90 triangle, which warned me that when I do this, I want to make sure I have exact answers. If I had done the trig, I would have got the 2.60 rounded at the bottom, but I would not have got the 3/2 root 3. So I would have got part of it, but not full credit. All right, thank you for watching this video, and I hope that it helps.